Fuck.
Okay, we are
Button.
live. We are live. We are here. How are
Are we
you
though?
doing? I
I'm
don't know.
good. I'm good. Let's find out. Let's find out. We need some kind of external validation. We need people to tell us that we're okay.
My hair
Come on,
is
Sydney.
not okay. I have got to dye my hair, and I feel the need. All of you watching on YouTube right now, I am aware of how bad my hair needs to be dyed.
There's a distinct line. I see it.
Yeah, oh, there's more than one. This is why my hair is pulled up.
Is it like layers you know, layers of rock?
Pretty much, pretty
Yeah.
much. You can see like this section was bleached at one point, this section was bleached at a different point and has been dyed multiple times without being rebleached. And so as stuff has faded, my hair is so many different colors, and then the roots are an inch long, and I'm aware of the problem.
Don't apologize for any of this. Okay?
This is why I
Seriously.
work with you. This is
Yeah.
why I work with you.
Yeah. 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 Like, I mean, for starters, I would love those kinds of problems, but also don't apologize for any of this. Who cares? Bring the science. That's the thing that we love you for. We don't care about the state of your personal hair tone colors. So, yeah, I know I speak for the audience when I say it's fine. Don't worry about it. It's fine. Yeah, you have more important things to worry about.
Oh, and
You have very important things to think about and worry about.
I have been working on software for comet
Yeah.
data processing, and that
And
has been
like
the
I know you can
priority.
multitask. I know you can feel anxious about two things at the same time
It's
and
true.
maybe even three.
Yeah.
But yeah. Man, what's going on? So I got my Sea Star. I don't know if you can see it in my background.
Is that what's on the little tiny tripod?
Yeah, right there.
It's cute.
So yeah, it's fun. It's very cool. So I like okay, so what do I hate about it? It forces you to connect to it as a Wi-Fi hotspot,
Oh, so you can't
which
connect to other things at the
so you
same.
can't connect to other things while you're using it. And like that's
I
just
hate
so
that.
terrible.
Especially when you
Be-
want to like be looking up what's the cool stuff up there right now.
yeah, exactly. You're out in the field, you're trying to use your telescope, and then you're like, well, what do I want to target? I don't know. Let me just check Telescopius to
Can't.
see what things are going to be featured. Well, I can, but I have to disconnect from the telescope, reconnect to my Wi-Fi or the the cell signal, look this stuff up, and then the telescope is just like, I don't even know who I am anymore. And then you have to reconnect to the telescope, and now you can't receive text messages, you can't receive any information, right? So don't get any notifications, and then you forget and you have no internet connection on your
Yeah.
phone for a while. So that's all bad. But while it's connected, it's just automatically taking pictures, and for the length of time that you're choosing, and then when the image is finished, it just drops it into your photo gallery on your
Yeah.
phone, which is kind of cool. So I've got all these photos that I've taken, and they're all just there. I got a shot of the Leo triplet, which was really cool,
Very
which
cool.
I call the it looks like sort of like two eyes and like just a mouth that's going meh. So I really love it. And it was great. It looks great. Like it's amazing. Like this tiny little telescope is taking these. I did like a 5 minute exposure, and
So
it was fantastic.
I need to ask you, did you catch satellites going through a random selection of your images?
Did I ever? Oh my
Okay.
God. So many satellites. Yeah. Yeah. Yeah.
The
They are relentless.
the reason I ask is there's a whole lot of people who I've heard make the comment, and I think this is like inspired by the Samsung Moon thing, which is just using AI to do stuff to images you take with your phone to the moon, where they're like, this isn't real, it's just downloading stuff that it has in memory and telling
Right.
you it's live. And the
Yeah.
fact that there's satellites tells you that it's
Yes.
live.
And there's a lot of
Yeah.
satellites.
Yeah.
So
It's disturbing.
yeah. But super fun. And so my plan is to like program it on a constellation that's rising in the east.
Yeah.
and that's going to be in full view. And then I'm just going to let it take hours long pictures of various things in that.
That's
Like
amazing.
spend like tonight, just do Leo.
Yeah.
And then just spend, say, an hour on the triplet and then an hour on some other object in Leo.
You
And then
should
that'll give me a sense of what's good and what's bad.
you should just pick up a cheapy secondary phone that you don't attach to cellular or anything.
Yeah, we have a backup phone, so I might,
Okay.
and I also have an iPad, so I'm going to
Yeah.
see if, if that'll do the trick. Because, yeah, we have an old backup iPhone 8, I think. So we'll try that.
Yeah.
All right, I guess we should do our job.
It's true. Okay. I need to find all of the record buttons. I have pressed record. I have
I've
pressed
also
record.
pressed record. Okay. Astronomycast, episode 753. Why is the moon's south pole so important? Welcome to Astronomycast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. We escaped tornadoes yet again. It is that time of year. And yesterday was the second anniversary of the first Starship launch. And it was super bittersweet because it was just like this promised giant telescopes in space and Artemis. And it's just so far behind on its deadline. And one of the things I realized you and I have said many times is no longer true, because when they first started on Starlink, we talked about how, well, with these giant rockets, they will be able to just launch 8-meter telescopes, no big deal, all the way into space. And it turns out that like the LSST is 330 tons and Starship will only be able to launch to Leo 100 tons. And so it's just sort of like, I have sad. I had much sad.
Oh, they could slim down Vera Rubin and put it, because it won't have to be in space.
I know.
So they could probably make it work. But yeah, I mean, like, turns out rocket science is hard. Turns out
Yeah.
this stuff takes longer. Turns out having a CEO who is busy doing other things is distracting
Yeah.
for the objectives of the company. So yeah, hopefully, maybe this time next year we will see orbital reusable two-stage rockets.
Hopefully.
I'm sure you've heard that all eyes are on the moon's southern pole. This is where various NASA and Chinese missions are targeting. What makes this region so special, and what are the special challenges that explorers will face? And we'll talk about it in a second, but it's time for a break. And we're back. All right, the moon, South Pole, why?
Water, cold
Water.
traps. And one of the things that came up last week, so there's two different lighting conditions that are kind of awesome, and we touched on this a bit last week. So there are places in the craters that, because of the angle that sunlight always comes in, the sun is just never at a high enough angle to get far enough into these craters to illuminate them. These permanently shadowed regions act as cold traps, which means that whenever water molecules end up in the super tenuous atmosphere of the moon, they settle back down and then can form ice and just accumulate inside these cold traps. Now, the other side of this is, just as the sun's angle never allows some of these areas to get sunlight, I made the mistake last week of saying there were permanently illuminated areas, and that's the wrong way to put it, because if you have an object that's like sticking up from the very tip of the South Pole, it's going to create its own shadow. So as the sun goes around, there's no point on this thing that is sticking up that is always going to be in sunlight. But you can stick up solar panels that just rotate over time.
Right, from the very top of the mountain.
You can stick up antennae that radiate in all directions. So you have these points that, as the moon turns, can always get you power and always get you get you communications.
Yeah, so we did some reporting on this about 6 months ago where researchers looked at various spots on the north and south pole of the moon and tried to calculate what are places that receive the maximum
Yeah.
amount of radiance. And so typically, if you're at the equator of the moon, you're going to experience 14 days of sunlight and 14 days of shadow. But if you get to the poles of the moon, depending on where the moon is, like remember, the moon is not perfectly aligned with the Earth's orbital plane, and the Earth's orbital plane is not perfectly aligned with the sun's orbital
Yeah.
plane. And that's why we get eclipses, that sometimes the moon is a little higher than the sun, and other times the moon is a little lower than the sun from our perspective. And so what that means is that you don't get equally distributed sunlight on the moon, but you do get places where it's down to 6 hours of darkness throughout the entire lunar month. So it gets very close, close enough that you could run off of battery for the time that it's down, or slightly move the position of your solar collecting satellite or your solar collecting panels, as you say, to try and keep in that sunlight. So it's, there's no guaranteed place that anybody's been able to find. But on the flip side, there are regions that are in permanent shadow, and there's
Yeah.
a lot of them.
And what is so awesome about this is like I was talking about last week, there's the thermal conditions. And one of the scary things about being on another world is the idea of not being able to be in communications with Earth if something goes wrong. And so being able to have that constant communications without having to rely on communication satellites, without having to build an entire communication satellite network, that is all just really, really important.
Yeah. So let's talk about this water, because I mean,
Yeah.
you say that there is water ice there. So one, do we know where it came from?
Well, I mean, we don't even know for sure where the Earth's water came from. So,
Fine.
just to be clear, this is one of those things where I can tell you things that we think about. Truth may ultimately prove out to be more or less interesting. So, in general, you do have bodies that contain water smash into the moon periodically. Comets, asteroids, chunks off of either of these objects. And when these water carrying things smash into the surface of the moon, no matter where on the moon it is, you end up with their moisture, their water, their ices, their volatiles getting mixed in. And sometimes they get sent into the atmosphere of the moon. Sometimes they get buried and they're able to
Right.
exist beneath the surface of the moon. But
No, hold on 1 second before people send you emails about there's no atmosphere on the moon. There is an
it's
atmosphere on the
super
moon.
tenuous. Yeah,
Yeah.
this is why the Grail mission existed.
Yeah.
It was out there measuring the super tenuous.
It is 10 to the -6 bars.
Yeah, but
So it is dramatically lower than even Mars. Mars is this ocean of atmosphere compared to the moon, but it exists.
and it is sufficient. And when I'm talking atmosphere, I'm talking about like a few molecules, to put this more in perspective, a few molecules of the volatiles that were in whatever smashed into the moon
Right.
float up and then land somewhere else.
Right.
And I just
Right, and so I
jiggled
guess
my
it-
desk, sorry.
And so largely they land somewhere and then the sunlight evaporates
Yeah.
them and they head off into space. But every now and then this
Go
stuff
down
lands
elsewhere.
in these permanently shadowed craters in the moon, and they have a
Yeah.
chance to join their friends and they stay there.
And it's
so
Brownian motion.
Yeah, it's amazing though. You think about it, like if you give any process billions of years to be carried out, it's amazing what can build up over time. And so it could very well be, as you said, that you've got these objects crashing into the moon. Just individual particles of water
Yeah.
are finding their way to the South Pole, and then they are freezing in these craters.
And there is some thinking that there are also probabilities of like comet smashes into moon, comet fragments end up in permanently shadowed region when they crash in, and they just live there forever. But
Right.
the probabilities of that is much to be debated.
And there's another theory as well about the solar wind, right?
Yeah. So you have The solar wind carrying all sorts of different particles and energy. And when it hits the surface, it can liberate particles, and you get hydrogen and oxygen liberated. There's a chance that they can mix to form water.
Right.
And you also,
So,
any ice that's there can get liberated.
right. So there was some research that just came out like this week. Is
I haven't
super fresh.
seen it, sorry.
Yeah. So the gist is that people have taken the solar wind, they've recreated or simulated the solar wind in the lab. They've blasted lunar regolith with high velocity simulated solar wind. And really, the solar wind is just protons.
Yeah.
And then other particles, but mostly protons. And so you smash the protons, as you said, with enough energy into the regolith.
Yeah.
You get the liberation of electrons, which join with the protons to create hydrogen atoms. And then they bond with oxygen atoms that have been liberated. And this creates water right in situ, right on the spot.
Yeah.
And this is a reasonable explanation for why people are even finding water throughout the regolith on the moon. It's just the sun is constantly blasting it with protons, and those protons are finding friends and turning into water, which is really cool.
And before anyone asks us, yes, when the moon formed from the great sploosh of proto-Earth and Theia colliding, that sploosh of low-density material inevitably did include water. That is part of the budget, but it's not at the surface necessarily. So yes, don't at me.
Okay. All right. We're going to talk some more about why this is so important. But first, it's time to thank our sponsors. And we're back. All right. So, we talked about water, and where it came from and why it's there. But why is water important for lunar exploration?
So it turns out human beings need oxygen and we need water. We are biological creatures. And it also turns out there's ways to process water and turn it into fuel. So you have the ability to create fuel, you have the ability to keep human beings alive. So send the robot overlords will need fuel. Send the humans will need water and oxygen. Send both are happy.
Right. Like break up water, turn it into hydrogen and oxygen. That's rocket fuel.
Yeah, exactly.
You've also got oxygen. That's for breathing. You've got water. That's for drinking, for growing plants. And then also a lot of the really interesting in situ resource utilization ideas for harvesting material on the surface of the moon requires large amounts of water.
Yeah.
And so if you're going to try and process elements, make titanium and stuff, you're going to need a lot of water.
And this is where, Moon is a Harsh Mistress is a really cool book to read because it talks about the idea of mining these resources and all of the issues of if you start exporting anything from the moon, you're now permanently removing a vital resource. So every time we launch a rocket using ice that is mined there, every time they don't fully recycle water and oxygen and the byproducts of breathing, so carbon dioxide, they are losing a resource, just like every time you use a helium balloon on Earth, you're using up a resource. So it's just cool to think that on the moon, water and oxygen play a similar role to helium on the surface of our planet.
Yeah. Okay, so we've got this sense that, this is why you want the water. And still from the and you've got potentially access to 24/7 power.
Yeah.
And those two come together to give us a good place. So who is currently planning to visit the South Pole of the moon?
Well, there have been some attempts that did not succeed entirely well. Most recently, we had one of the CLIPS missions, Odyssey. It hit the South Pole and skidded for a while and then died a terrible death. So there's it lying there dead.
Right.
We also have Chandrayaan-3 that has been more of a success. Landing near the South Pole. That's part of the Indian super successful. The Chandrayaan missions are just sweet. And
Chandrayaan-2 failed, but 3 succeeded.
Yeah. And we're hoping to land Artemis 3 there with human beings. China is, I have to admit, have they gone or are they planning to go?
Well, China has landed a sample return mission on the far side of the moon, and they've landed near the not not at the South Pole, but closer to the South Pole from the equator, and on the far side of the moon, and retrieved samples back to Earth. But they are absolutely planning
Oh, yeah.
on going to the South Pole of the moon, and the same reasons why NASA is planning to do with the Artemis missions.
And one of the super frustrating things for a lot of planetary scientists is the Viper mission that was previously the lunar resource. I forgot the third word, mission. So this is something that's been under development since around 2015, has changed names along the way. It is done. It is tested. It is complete. It is ready to go. And
Its
it is
flight to the moon has been paid for.
and they're not sending it
Yeah.
because
But I mean, now under the light of sort of the current cuts that we're looking at for science,
Yeah.
I mean, we may see Nancy Grace Roman get cut. We probably will see the Mars Sample Return mission get cut. We're probably going to see
literally
all of
everything but
all of it,
HST.
all of it. Yeah,
And
Habitable Worlds Observatory, like,
Yeah.
there's going to be maintenance, and so these smaller missions, Viper, Titan Dragonfly. Well, because Titan Dragonfly's not a smaller mission, but anyway,
Yeah.
these are all just collateral damage to potential significant science cuts
Yeah.
to NASA. So yeah, it doesn't surprise me that Viper might, I mean, it was already on the chopping block even before we saw the recent suggested proposed budget cuts, but.
Yeah. I've covered this over on Substack. Yes, I need to move things off Substack. And we've covered this with Escape Velocity Space News. We actually, this week's episode is going to be talking about the human impacts of the president's proposed cuts. I do have to say, though, other nations are really picking up, and this is where looking at what China and India are doing is so cool. You have Japan's iSpace isn't aiming towards the pole. It is actually in June looking to land mid-northern latitudes, like 60-ish degrees north. But if iSpace, which is doing slow and systematic testing and development, it's going to be on its way as well. This is the new Wild West. It's now the Wild South, and it's dominated by robots. And I'm here for it.
Now, this is a completely separate rabbit hole, but there was a presentation at the 40th Space Symposium where a company that's working on isotope, like radioactive isotope thermoelectric generators, that they're planning to install a isotope on an upcoming iSpace mission to the moon, which will keep it warm through the dark, cold lunar night.
That's
and
awesome.
so, yeah. So you can see ideas for how you could keep these spacecraft warm and producing electricity month after month after month. Because normally they die, right? Most of these landers are dying as soon as night falls on the moon, but maybe there's a way to continue further. All right, we're going to continue this conversation about the South Pole of the moon, but it's time for another break. And we're back. So, okay, so we've got an understanding of why the moon is important. We've got an understanding of sort of what current missions are there. So explain what a future path might be for a return to the moon, and specifically going to the South Pole.
So what we're looking at is by robot or human, and most likely a combination of both. First landing outside of a crater, someplace sunny. If you want to die, you land at the bottom of a crater.
Right.
So land somewhere high up, like Firefly Aerospace did. Get all those solar rays. And then from your lander, the next step that we're hoping to be able to do, and this is what makes that failed Odyssey and all of its things on board so frustrating, is they had on board a rover that was going to go drive itself into a permanently shadowed region. And this is what we want to do, is first of all make sure, yes, we can do this. Yes, we can navigate, we can not die. Because trying to get auto-driving cars going on the planet Earth is complicated enough, and they have headlights and roads and all that sort of stuff. So now we're looking to drive a rover on the moon into a permanently shattered crater. So we have to figure this one out before we send people. So that's on the to-do list. There's some really cool plans where some programs have tethered little guys. Some companies have big old rovers that look more like something that you might have built in high school and raced around a track, or from Junkyard Wars. These are our future, is figuring out how do we navigate down into craters that can have angles of repose we can't even imagine on the planet Earth. This is the angle at which soils, regolith, dirt, whatever the stuff of the ground is made of, are able to exist at before they collapse in landslides. Because the moon has significantly lower gravity than our world, you can end up with these like kilometer deep, sharp drop-offs.
Did you watch For All Mankind on Apple TV?
Yes.
So there's, I think it's in the second season when they are building bases on the moon. They've got just an incredible description of this and sort of showing how this would work. They've got the Soviets and the Americans have bases on the rim of a crater in the South Polacan Basin.
And the winch system.
Yeah, and they're having to winch down into these incredibly steep craters that are in permanent shadow, and all the challenges go on, and all the political challenges between them. It's just terrific.
Yeah.
And if you really want to kind of wrap your mind around that, I highly recommend For All Mankind. Yeah.
Yeah, and so we need to figure out. There's going to be a whole lot of infrastructure needed. We need to figure out just how to consistently land. So all eyes are on these CLIPS teams on Blue Origin with their Blue Moon. We're hoping Starship catches up at some point. And this is what's going to first take our robot colleagues and collaborators there and allow them to build the infrastructure we need, allow them to explore safely, allow them to figure out just what is possible. And then both China and the United States are hoping to put a first transitory set of humans on the moon and then eventually build research stations there.
Yeah. So right now the Chinese have put 6 probes down onto the surface of the moon. So Chang'e's 1 through 6.
Yeah.
Chang'e 7 is the next one. That's going to be launching in 2026. And that is going to the South Pole of the moon. And it is going to have a suite of cool stuff on board. So it's going to have a rover. It's going to have a lander. It's going to have a mini hopping probe that is going to jump around on the surface of the moon to demonstrate if that's a really good way to do locomotion. I don't think it's going to do a sample return, but and then the eighth one, the eighth Chang'e, is going to also go to the South Pole of the moon, and they're going to be testing in situ resource utilization. So they're going to try to 3D print material out of the regolith. It's going to scoop it up and try to spit out Lego bricks and things like that onto the surface of the moon.
And one of the really cool things, the first time I saw this research, it was out of a University of Tennessee or Tennessee State, I don't remember which, research team, where they figured out that if you zot lunar regolith with the correct wavelength of microwave light, it solidifies. Right. And so you can start to imagine that instead of street cleaners that have brushes making our roads, you instead have something with a microwave reflector on the bottom that is just going along and making the roads as it drives. And controlling dust on the moon, we cannot stress how important that's going to be. This stuff is nasty. And the more you can solidify and dust-free a region so that when things come in for a landing, when someone walks, all these just basic, you're trying to get from point A to point B kinds of existences, don't do you in because of the dust. And the other thing that we haven't talked about is there's all of the radiation concerns, and this is again something that came up in For All Mankind, where when you're on the moon, you're beyond the Earth's magnetic
Yep.
realm of keeping us safe. And when there's solar flares, if you're in a crater and you can duck into a cave on the side of the crater, that is a way. If it's permanently shadowed, it's not going to blast you.
Right. Yeah, you know that it's safe. It's been
Yeah.
there for billions of years. Yeah. Yeah, and people don't realize, like, just the background radiation
Yeah.
is about 200 times what you would experience on the surface of the Earth. So it's a lot of radiation. That's the cosmic radiation, and some radiation coming from the sun. But in a bad solar storm,
Yeah.
you'll receive a lethal dose of radiation in an hour.
Yeah.
You're straight up dead
Yeah.
if you're caught out in a bad solar storm. And again, they cover that in, as you said, they cover that in For All Mankind. It was phenomenal.
Yeah.
Yeah. So let's talk about sort of the human return to the moon. You know, we've talked about this a bit. So
Yeah.
for Artemis, the plan is Artemis 3, 2027.
Yeah. And the original plan was launch on, so the original plan was Constellation. Current plan is Space Launch System with the Orion capsule. Launch to orbit, dock with a Starship HLS, so human lunar system, human landing system, which is supposed to...
Do they dock it in Earth orbit or lunar orbit? I think they dock in lunar orbit.
It depends on which set of plans you're looking at,
Okay.
honestly.
Yeah.
And originally there was the Deep Space Gateway, which comes and goes
Right.
in the current plans depending on whose budgets. Everything is in flux, I think, is the key right now.
Yeah.
Because it's been recognized, and our friend Dustin over at Smarter Every Day did an amazing video that is on my must-watch list for everybody
Yep.
on just how complicated refueling is going to be and how much harder it's going to be than what a lot of people think. So
Yeah, I mean, they're estimating 15 to 20
Yeah.
refueling launches. Yeah. And like so far, like, I mean, right now, Starship hasn't been able to both launch the Super Heavy booster
Yeah.
and Starship successfully and retrieve them back
Yeah.
at the launch pad. They haven't demonstrated transferring cryogenic propellants. We are in 2025. You know, when you think about the stack that needs to happen, I mean, they need to launch they have to demonstrate this orbital capability.
Yeah.
They need to demonstrate cryogenic transfer. They need to build and launch the human landing system. They need to send it to the moon.
Yeah.
They need to demonstrate that the human landing system can go down to the surface of the moon and come back up into orbit to prove that it's ready for Artemis 3.
we need
And
order of 60 launches before, and so that's the
I don't
issue.
know about 6.
No, because you have the test flight, which is going to be 20. You have the human flight, which is going to be another 20 for refueling.
my understanding was that it's the one is going to go there, and then it will first do a test, but then it will still have enough fuel in the tank to then do a human landing.
Okay, so that was the information
Yeah,
that I had
yeah.
wrong.
You don't need multiple HLS, just the one.
Okay.
Yeah, yeah. But still, so I mean, I guess what we're saying is prepare yourself emotionally for delays.
But NASA is
That-
already starting to consider not using HLS for
Right.
Artemis 3. And this is where Blue Origin's Blue Moon program starts to get so exciting.
Which also doesn't exist yet.
Correct. So we're
Right.
going to have two different don't exist competing. Yeah.
Yeah, yeah, yeah. So again, 2027 is the planned date. No one has told you that the date is going to be otherwise, but do not be surprised when the date becomes, otherwise.
Yeah.
Now, on the Chinese side, things are moving full steam ahead.
Yeah.
So they're planning on launching 2 Long March 10 rockets. One is going to contain the crew capsule and the service module. The other is going to contain the lunar lander and the ascent module. They're both going to fly directly from Earth to the moon. Then the crew is going to dock, just like in the Apollo missions. The crew is going to get into the lunar lander portion, and then you're going to go down to the surface of the moon. They're going to do their mission around at the South Pole, get into the ascent module. It's going to launch off the surface of the moon, dock with the command module and service module, and then they're going to return home. They're going to ditch the ascent module, and then eventually ditch the service module, and then return back through the capsule. And this has all been played out in the existing sample return missions. That, the whole
Yeah.
point of the sample return, of multiple sample return missions, is they are testing out each one of these pieces. Now, they're going to have entirely new hardware, entirely new rockets, but, two rockets launching together seems relatively feasible and a
Yeah.
lot less complicated than what's going to happen. But it's a lot less sustainable. You're throwing away every single part of all of those rockets, just like you did with the Apollo era. While with Starship, the all of the boosters are reusable.
Yeah.
All, the Orion capsule is reusable, and then Starship, I guess, is reusable, even though it's going to be out at the moon. It's that you lose all of the, parts of the SLS. But
And the thing to think about is China has the human budget, the natural resources budget, and the dollars budget that they can afford to throw things away during innovation.
yeah,
And
even dropping rockets on villages
villages.
downrange, right? Like whenever we talk about this kind of stuff, and people are like, yeah, but they drop rockets on villages, and you're like, yes, they do. Yes, yes,
We are aware.
We are aware. That's the price that they're willing to pay for their citizens to be able to accomplish such a fast moving thing. And like,
Yeah.
we do not, I don't approve of that. I wouldn't, that's not a cost I'd be willing to pay.
Yeah.
So in theory, we'll see many more missions to the moon, and we will see humans to the moon, hopefully by 2030
That's
and
the
onward.
goal. I really think that one nation will have humans to the moon by 2030. I just don't
Yeah,
know
me
which
too.
nation.
Right.
All
Yeah.
of the above. All of the
All,
above.
yeah, all of the above. And there will be this time. I would like right now when you see the International Space Station fly overhead, and you're like, wow, there have been people in space on that thing continuously for 25 years. And there will be a time when you'll be able to look at the moon and you'll say, there's people there.
Yeah.
Always. Still there. Doing research. Sending home pictures. It's going to be so cool.
It is. This is the future we want, and I just want to acknowledge real fast that there have been a whole lot of planetary scientists here in the U.S. who have been just like, I'm not going to retire until we land humans on the moon again, because like they joined during the Apollo missions, they were in college for the Apollo missions, and
Yeah.
no return to the moon has occurred, and a lot of them are now looking to retire because they recognize.
Don't retire.
But the thing is, they're doing it to leave space so that there's budget for younger people. And I just want to thank all of the elder planetary scientists who are retiring so that
Yeah.
younger humans can have jobs. It's just heartwarming and devastating. It's sort of like when you hear the kid raised the money to pay off the school lunch debt. It's awesome, but why did that have to happen?
Yeah.
So, yeah.
Wonderful. Thanks, Pamela.
Thank you, Fraser, and thank you, patrons. Like the two of us get to do independent science journalism, where I can talk about what's going on in the United States. Fraser can talk about any science he darn well feels like anywhere on the planet, and we here in Astronomycast can speak without worry about getting a call from some program officer, because all of you are out there funding what we do. So we can't thank all of you by name every episode, which is a great problem to have. But this week, I'm going to thank David Rosetter, Travis Porco, Mike Heisey, Jonathan Poe, RJ Bask, Jimmy Drake, Bob Krell, Tricor, Noah Albertson, Ryan Amari, Mike Dogg, Simeon Torfason, Mark Schneidler, Michael Purcell, Jeanette Wink, Brian Cagle, Jason Kwong, Tiffany Rogers, Robert Plesmo, Laura Kettleson, Frodo Tenenbaugh, Red Bar is watching. A pronounceable name. Jeremy Kerwin, Kensayo Penflanco, share some The Lonely Sand Person, Scott Briggs, Benjamin Cryer, Jim Schooler, Marco Iarasi, Nyla, David Green, Smansky, Rando, Benjamin Mueller, Benjamin Davies, Planetar, John Drake, Bruce Amazine, Paul L. Hayden, Jeff Hornwarder, Pauline Middlelink, Jordan Turner, Robert Hundell, Taz Tully, and Lee Harborn.
Thanks, everyone. We'll see you next week.
Thank you. And then they saved.
And then they saved. 7:53.
Yep. My brain just turned off for a moment. I don't know if your brain has ever done that.
Well, yeah.
We had storms last night, and I had a very anxious dog, and I've lost my mouse. Where is it?
You check the thing that you're holding onto with your hand.
If only that would let me figure out where its point went. Okay,
Okay.
it's on that screen.
I'm uploaded and safe.
I now have my cursor on the correct screen, so I feel better.
Okay.
Okay.
You ready?
Yeah, now I am.
Okay. Let's do some questions.
Excellent.
Alan Gross, is the South Pole to be preferred over the North Pole?
Yeah, just because Shackleton Crater is kind of awesome.
And there's just like more permanently. Are there
Yeah.
more permanently shadowed craters in the South Pole than the North Pole?
Yeah, it just happens to be a fluke of geometry. Not geometry, geology. Shackleton Basin, Schrodinger Basin. There's these just glorious craters all over the South Pole. And the North Pole has craters. They're just not as deep and glorious.
Oops. Oh. Yeah, eternal darkness near the North Pole.
It's there. It's just not as there.
Yeah. Yeah, so there are, but just not as many. Okay. Raj Luthra asked a bunch of good questions as always. Will it be safer to mine the asteroid belt and other locations than the moon, considering how important the moon is to the Earth?
No.
No.
Actually, the safety of the moon is, I mean, it doesn't have the resources we'd probably be looking for. But the thing about the moon is it has enough gravity that that's going to help keep the humans doing the mining safer. It is in a secure orbit going round and round the planet, so we're not going to accidentally move it somewhere we shouldn't have. And mining asteroids is just, they're fragile and we don't understand them well.
Yeah.
So you have stuff that's cool and geologically diversified, like Ceres, which is really big. But then you have the rubble piles like Osiris-Rex that you can accidentally plunge into.
Yep.
And being able to accidentally plunge your spacecraft into a ball pit of an asteroid just feels like a really bad thing.
Alan Gross also asks, is landing at the South Pole of the moon more difficult than landing elsewhere on the moon?
Oh, yeah, totally.
Yeah. Way harder. Yeah.
That complex geology, the having to get your computer vision to navigate around all.
Well, but it's just it's the delta V. So
Yeah, there's
when
that
you
as well.
go to the moon, right, the moon is orbiting in the Earth's orbital plane. It's like 11 degrees off of the Earth's orbital plane. But so you go into orbit around the Earth, and then you fly out to the moon, and now you go into orbit around roughly the equator of the moon. And then you find a landing place and you land. But if you want to go to land at the South Pole of the moon, then you've got to change your orbit from an equatorial orbit around the moon to a polar orbit around the moon. And then you find your landing spot and then you set down. That's a ton more of delta V. Now, there's some cool tricks you can do using the moon's gravity for slingshots, but that adds time. You can use the Earth's gravity for slingshots. Like, there's a bunch of stuff that you can do to get you into a better position. But no, it is dramatically more propellant required to do this.
It is much harder to land in a lumpy, bumpy, cratered surface than in a nice, flat plane.
I mean, there are lumpy, bumpy cratered surfaces all over the moon,
Yeah.
and there are them. But there's a bunch of other issues as well. There are steep slopes on the flanks of these craters that are really interesting
Yeah.
that are potential landslide hazards. And so people have identified places that are, you mentioned what was it, the slope?
The oh geez, the words just left my brain.
Yeah. That's like the steepness of the slope that you
Yeah.
get from just material piling up on top of itself.
Yeah.
And that is, and so there are places that are right on the very edge of it, and they found landslides. They found rocks rolling downhill. And so they need to find places at the South Pole of the Moon that are close to interesting scientific locations, but are also flat enough that you're not going to get landslides that are but also potentially have protection from storms if necessary. So there's a lot of factors, and we've done a ton of reporting on this on Universe Today about various teams that are narrowing down the potential landing sites, and they're down to a few dozen right now.
Yeah.
And we will know the final location before they launch.
And it's angle of repose. When you said
Angle of
slope, it
repose.
erased everything from my brain. Angle
Yeah.
of repose.
Rajluta also asks, are there any plans for a telescope to be placed at the South Pole?
I mean, people always talk about putting
Yeah.
telescopes. Right now, I saw
No.
not on the South Pole. The far side is what they keep talking about. For radio,
I mean, they talk about both, right?
Yeah.
So the far side, the radio telescope, there's a lot of really interesting ideas. None of that is concrete, but there's some good
Right.
ideas. They talk about the South Pole telescope idea is a fairly old one. That the plan was that you could put a telescope into a crater
Yeah.
at the South Pole of the Moon, an infrared telescope in one of these permanently shadowed craters, and then it would be pointing in only one direction, but it's very, very cold in there and remains cold. You don't need a sun
Yeah.
shield the way you did with James Webb. But the absolute best idea that so there's two ideas for the Artemis mission that one is with the CLIPS program. So there's a proposal in the works for an interferometer, an optical
Yeah.
interferometer using an incredibly small telescope. So what you'll do is one of these CLIPS landers will sit down on the surface of the moon, and then it'll have a telescope that's pointing up or in some direction. And then a tiny little rover with a little telescope will drive out about 100 meters away from the lander, and then it will look up at the same point that the lander is looking up, and you get an interferometer. And it will be the largest optical interferometer that humanity has ever made, because it will have a 100 meter or a 200 meter or a 1 kilometer baseline. But the telescopes themselves are really small, so you can only look at very bright objects. And the idea is that you could then look at, say, Betelgeuse, and you could resolve features on the surface of Betelgeuse or Rigel or other big bright stars that has, with a level of, you could see sunspots on the surface of Rigel and things like that. So that's an idea that I really like. And then a sort of juiced up version of that is that when the Artemis astronauts arrive, maybe not the first launch, but later on, they could set up a physical telescope interferometer on the surface of the moon and then separate the telescopes as far as you need. So you could go, you could set up these telescopes a kilometer apart, and the astronauts would literally, hop in their moon buggy and drive out this telescope and install it on a pier out far away, and you would get this giant network of telescopes on the surface of the moon that would do this. So I've got a bunch of videos that I've done about this, but the moon is a really exciting place to put telescopes, and not just radio telescope on the far side of the moon.
And Moonlight is the name of the interferometer, and I'm trying to figure out what launch it was on, because I have this terrible, terrible feeling that it was part of the one that just went blank.
No, it hasn't.
It wasn't?
been,
Okay.
It hasn't been developed yet. No.
Okay, good. Yeah, it's called Moonlight. There's papers on it in
Yeah.
PhysOrg and SPIE and Archive
Yeah.
on your website. That was just the fifth link. So go to the Universe Today one, Studying Stars from the Lunar Surface with Moonlight.
There you go. Yeah. I love the idea. Like, I interviewed
Yeah.
the researcher behind this, and it was just such an incredible idea. The fact that this would be the most powerful interferometer that humanity has ever launched, and it just like tells us how important space-based interferometers are going to be. You've got this physical place that you can then set down a telescope, and it will be solid. And then you could just like slowly tweak it to make sure that everything is all nicely dialed in. I love the idea. They also propose that you could, now this isn't specifically on the surface of the moon, but people have proposed that you could do seismology by having telescopes on the surface of the moon, and that they would, as they rise and fall, they their interference patterns get out of sync, and then that is it, you're getting measurements of earthquakes on the moon.
One thing we
So
didn't bring up that saying the word earthquakes triggered is the effect of how the moon isn't perfectly aligned. We aren't always seeing exactly the same half due to the geometry of its changing elliptical orbit is called librations. And there's some really cool animated
yes.
GIFs out there, GIFs, I don't care how you say it,
Yeah.
showing just that change in both the size and the angle that we see the moon at.
NASA's Goddard facility releases
SVG, yeah.
they release a prediction of a simulation of the moon for the upcoming year.
Yeah.
So they do it at the end of each year. And so do a search for like NASA Goddard Moon 2025 or something like that. And then watch this video. It is a simulation of the entire moon every single day
Yeah.
through the entire year. And the moon, as you say, it gets closer and farther and closer and farther, but also because of this alignment, it looks like it's sort of wobbling in
Yeah.
view. It's absolutely a sort of a breathtaking thing to watch.
Yeah.
And yeah, so I think we get an extra 15% or something like that
Yeah.
of the moon that we can see because of these changes of angle. It's amazing.
And if you are using any NASA graphics, anyone out there for your work, your education, any of that, they're trying to collect all that data right now. So if there's any NASA website you've used a whole lot, reach out to those people and say, hey, here's a bibliography of how I've used your work.
Right. That would take me a long, long time.
It would, but what you can do instead is say, I use your site at least this many times per month in articles.
Per day.
Yeah, exactly. It
Yeah.
depends on the site. I'm sure there are some NASA sites you don't go to every single day.
That's true. That's true. Yeah. 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 I mean, like, what a fluke. I had no idea when I started Universe Today, but the fact that almost all NASA images are released public domain
Yeah.
is just incredible. Does anyone else? Are there any questions over on Twitch?
How powerful of a scope would be needed to see the landers as they arrive? This is being asked by Existential Squee.
So the current telescopes, the largest telescopes on Earth can resolve features on the surface of the moon down to about 50 meters.
Yeah. So Lunar Reconnaissance
bigger.
Orbiter in orbit, because it's closer, has a greater
Yeah.
angular resolution. So
Yep.
the key is to
Yeah.
coordinate with Lunar Reconnaissance Orbiter, which has the best cameras. That may eventually get supplanted by either the Chang'e series or the Chandrayaan series. But right now, Lunar Reconnaissance Orbiter still has
Yeah.
the highest resolution.
But it's funny. So like right now, that is like the biggest telescopes on Earth, whatever,
Yeah.
8.5 meter telescopes. But you can imagine, okay, so when the extremely large telescope comes online, now you're looking at, say, a 39-meter telescope. So maybe now it can resolve features down to 10 meters across. So there might be a day, there
Yeah.
might come a day when we have a big enough telescope on Earth that you actually could resolve landers and stuff on the surface of the moon. But yeah, you look at images from the Lunar Reconnaissance Orbiter and they're incredible. Like you can see the Athena lander sitting in a crater
Yeah.
on its side. You can see all of the various missions taken from space. You can see the footprints of the astronauts during the Apollo era when they were walking around. You can see the tracks left from the vehicle. So it's incredible. So
Yeah.
these images are there, but no, we can't see them from Earth. But absolutely, they will time orbiters to capture them as they're falling.
Yeah, they do the same thing at Mars using Mars Reconnaissance Orbiter, and those are sister spacecraft with very similar instrumentation. It's just MRO is higher up because bigger gravity well. So it
Yeah.
doesn't have quite the same resolution, unfortunately.
Yeah, there are
High rise.
pictures of Perseverance deploying its parachutes seen from space
Yeah.
by the Mars Reconnaissance Orbiter. They time it.
Yeah.
They time it so that they can see that everything is deploying properly from space. It's bonkers.
It's amazing what we're able to do. Yeah, go check it out. And if you haven't looked already, there's some amazing time lapses of building the dome for the extremely large telescope. Like
Oh,
it
I haven't seen
doesn't,
that.
yeah, it doesn't come home just how massive these things are until you see basically the slit in the dome is big enough to put the entire dome of other telescopes through. It's just sort of like, oh, that is
Yeah, that's
big.
big. That is a large
That's going to move.
telescope. Yeah,
The
yeah.
idea of what we are going to be capable of moving is
Yeah.
shocking.
The extremely, like, I think people are not prepared for how
No.
powerful the extremely large telescope is going to be. Again, we've done a bunch of reporting on this. It couldn't detect the atmosphere of a Neptune planet in about an hour. It could detect,
Yeah.
it could measure biosignatures in the atmosphere of an Earth-sized world orbiting around a sun-like star in about 10 hours. So it's just like it's a ludicrously powerful
Yeah.
telescope. And it makes you sort of dream of what could have been if they ever had actually designed the or built the overwhelmingly large telescope, which was
Yeah.
going to be the 100-meter version
And
of
had
the
a better
extremely large
acronym.
telescope. Yeah, I mean, I love all these acronyms. They're but the OWL,
I was
and
a fan.
then people propose like you just build the OWL on the moon instead,
Yeah.
so you use a lot less structural elements to pull it off. So
But then
I
the
could just
amount of
imagine.
fabrication you have to build, though, to be able to do it. Because, like, we have the Arizona Mirror Lab, we have Kodak,
Yes.
we have.
Yeah. Yeah. How do you do that on the moon?
Right, right.
Yeah. Yeah. It gets tricky to do that kind of stuff on the moon. And that's why radio telescopes on the moon are such a cool idea because you can literally just gobble up regolith,
Yeah.
spit out wires, and you got yourself a radio telescope.
Yeah, it's cool. I'm apparently just going to say that phrase over and over because
It's cool.
yeah, this stuff is just like, unfortunately, we've been talking about this stuff for the entire 18 years that this show has existed, waiting for it to come into existence, and it's just not doing it. But we're going to keep going until it does.
Yeah. Yeah. Exactly. So we're kind of closing in on the end. What interesting stuff have you got coming up, Pamela?
Sorry, this is the look of what am I allowed to publicly talk about and going, nope, nope,
What
nope.
things coming up are you publicly allowed to talk about, Pamela?
So I am still waiting for one of the scientists I work with to get back to me about launching a website, but I'd forgotten he was one of the researchers involved in the Lucy mission. So he was posting earlier today on Facebook about getting to meet Donald Johnson, who found the Lucy fossil while doing the mission data. So apparently I am looking forward to the data from Lucy and my scientist being freed up to approve launching a new citizen science project. So as soon as he gives me the approvals, and I am in the process of, this will be relevant to maybe one person out there, doing the front end interface for a new Comet data reduction modeling software tool. So hopefully that will be done this week, allowing you to better model comets. The one person out there who might be using Charles Chambon Nolan, I can't pronounce his last name, he's a wonderful human being's last name, to use their simulations.
Cool.
Yeah, I'm writing a lot of software is what I'm doing.
Good. So for my side, of course, I've got my live question show tonight at 5 p.m. Pacific time. And then I got two really cool interviews that I'm really excited about this week. So one I'm going to be doing, and then I'm sure we'll release them as quickly as we
Yeah.
can. So one is with Daniel Engerhausen, and I have interviewed him in the past. He is one of the people behind the Large Interferometer for Exoplanets, which is like the competing idea to the Habitable Worlds Observatory. It's the European version of it.
Yeah.
And it would be multiple spacecraft flying information like the terrestrial planet finder. And he just came up with a paper last week about sort of what would give us a null result.
Yeah.
And so how far away, if we look and we don't see any evidence of life, to varying distances, what does that tell us about the chances of life in the universe at all? And then the other one, and this one I'm really excited about, is I'm talking to Edward Ajhar, and he's the director of the Vera Rubin Telescope. And so I'm going to be getting all of the cool behind the scenes information about Vera Rubin.
They have looked at the sky. They posted on their Facebook. They haven't put out the press release for official first light, but they have opened the camera up to look at the sky, which feels like first light, but they're not. So like they've had first light, but they haven't had first light.
Yeah.
It's exciting.
Yeah, it's really exciting. Oh man, I'm so stoked. Again, I think people are not ready for what this telescope is going to do. That it's just going to be this fire hose. Oh, we found another 1,000 supernova tonight. Just like, what?
Yeah.
Yeah, 500 supernova a night.
And it's a multinational collaboration. So even if the US is just like, nope, it's built, it's there.
Yeah.
Just go operate it for us, please.
Yep. Yeah. All right. Well, we've reached the end of our time. Thank you, everybody, for watching us. Thanks in advance to all of the editors and producers who are going to have to deal with all of the nonsense that we have unloaded upon you today. We appreciate you. I'm sure at this point, Pamela's making a little heart thing. Or this one. There you go. Thank you. Thanks for the moderators. Thanks to everybody who asked questions in the comments, both on YouTube and on Twitch. And we will see all of you next week. Thanks, everyone.
Bye.